All right, I'm here at the Children's Museum of Virginia, located in Portsmouth, Virginia. And this is Leslie Bowie, the museum's curator. Hi, Leslie.
Hi, Van. I understand you want to learn about sounds.
Yeah, I want to learn about how sound works, and especially how sound travels.
Well, let's have a look at some of our exhibits and get the answers to those questions.
Okay.
The Children's Museum of Virginia is a place where kids can experience science firsthand. Here they can feel it, touch it, explore it, learn it. Let's first consider how sound is produced. When sounds travel, we actually are hearing how the vibrations affect the air molecules. A way I can demonstrate this is with the slinky. Van, hold the other end, please. What we perceive as sound is due to the alternate squeezing and stretching of molecules through the air. This we refer to as sound waves. Sound waves travel through the air at 344 meters per second. They travel slower than light. You can see this for yourself the next time you see a thunderstorm. You can work out how far away the storm is from you by timing the interval between the lightning and the clap of thunder. A storm is about 1 mile away for every 5 seconds you count, or 1 kilometer for every 3 seconds. Now that you know what sound is and how fast it travels, let's do some testing. What do you notice?
The longer the tube, the lower the pitch.
Well, sure. The air molecules in the long tube vibrate more slowly, producing a lower sound. Higher sounds vibrate more quickly. The difference in the number of vibrations per second we refer to as pitch. Want to try?
Okay. Cool.
We can also use a recorder to demonstrate pitch. You use your fingers to lengthen and shorten the tube and create higher and lower notes.
Well, that's great, but how do you make it louder?
Well, with a recorder, just simply by blowing more air into the tube. But there's another way to make sounds louder, and that's to focus sound. Let's come have a look.
Okay.
Here, the parabolic dish collects sound from a huge area and funnels it right to this point. If you're standing in just the right place, you can even hear a whisper.
So, Van, why was Mr. Murphy only bothered by your sound?
Wait, somebody just asked me about Mr. Murphy. Who asked that question?
Well, Van, I'd like to introduce you to Dr. Lynette Roth. Dr. Roth is an audiologist. She specializes in hearing problems.
Oh, you mean like Mr. Murphy? Well, the question I have is, how come he singled out my band when there were so many other noises in the neighborhood?
It might be, Van, like many older people, couldn't hear the higher frequency of noise that came from the other sound sources.
The higher pitches? Why?
Let me explain how the ear works first. Sound waves travel through the air and enter the ear canal, causing the eardrum to vibrate. The vibrations from the eardrum cause the 3 bones in the middle ear to move. The last bone is called the stirrup. The stirrup is attached to a thin membrane. On the other side of this membrane is fluid, housed inside a curled snail-shaped tube called the cochlea. The vibrations from the stirrup causes this membrane to flex, which in turn sets the fluid into motion. The moving fluid tickles thousands of delicate microscopic hair-like cells called cilia. The cilia convert the vibrations into electric nerve impulses, which the brain interprets as sound. High frequencies are heard by the cilia at the beginning of the cochlea. Lower frequencies are heard at the end. If sound intensity is too great, or if it happens for a prolonged period of time, the cells will die at the beginning of the cochlea. Sound energy or intensity is measured in decibels. Generally speaking, the human ear can comfortably hear between 10 to 80 decibels. A quiet library typically registers between 40 to 60 decibels, while a loud rock concert registers above 110 decibels. Van, it's likely Mr. Murphy has lost some of his ability to hear at high frequencies.
So this explains why Mr. Murphy singled out our band.
Yes, Van, but I'm more concerned about the ear safety of young people, and in particular the noodles. Be careful how loud you practice your music, not for Mr. Murphy's comfort, but for your safety as well.
You bet. Dr. Roth, Mrs. Bowie, thanks for letting me come over to the Children's Museum of Virginia to learn about sound and how the ear works. Okay, I now have a better understanding of the science of sound and how people hear, but how do I control the amount of sound coming from my garage? Well, to find the answer to that, we're going to go back to Shelley at NASA Langley to see what she's learning about noise abatement. Perhaps she can pick up a tip or two I can use. Meanwhile, I'll share this information with my band, and I'll catch you later.